So for larger value of x, there is more increase in y with respect to x. As we can clearly see here, for the increment of 1 unit, let's say, of x, the change in y is much high. For the same change of 1 unit, if you assume here, the change in y is much less. So dy by dx, we can see from dy by dx is equal to 2x. So dy by dx for larger value of x will be high. So change in y with respect to x is going to increase as x is going to increase. You have to think in that terms. You have to learn to think in terms of dy by dx. So dy by dx is equal to 2x in this case. Now suppose you have to plot the graph using, suppose you have to plot the graph of y is equal to x squared. Then what you should do from now is differentiate this. Find dy by dx, that comes out to be 2x. Now you understand that dy by dx is rate of increase of y or change of y with respect to x. When x is changing, by what factor y is changing? Now when x is changing, y is changing 2x into the change of x. If you see from here, dy is equal to 2x into dx. So if we keep change in x constant throughout the x-axis, then change in y is actually dependent into x, and that is 2 into x into change in x. So for higher value of x, dy is going to be much higher, is increasingly going to be higher. So y, if you start for a small unit of x and increase y, then for the next same amount of a small unit of x, change in y has to be higher. For the next, it has to be still higher. For the next, it has to be still increasingly be higher and higher and higher. The steepness of the curve will actually increase, and since it's an even function, the same would be for on the other side of the graph. So the graph would be actually something like this. So this is just practice of what we are going to have ahead in the course. So I'm trying my best to help you understand what this dy by dx is. Dy by dx is change in y with respect to x. Now if we have to find what is the rate of change of y with respect to x at x is equal to 1, then all you have to do is find the expression of dy by dx and put x is equal to 1. For example, in this case, the expression of dy by dx is 2x. So dy by dx is 2x. At x is equal to 1, dy by dx is 2. That means y is changing with twice the rate of x at x is equal to 1. At x is equal to 2, y is changing 4 times the rate of change of x. At x is equal to 8, y is changing 16 times the rate of change of x. That means as you keep on increasing x, the rate of change of y is just going to increase. That's how the curve should be. Okay? In case of linear equation, change of y with respect to x is going to remain constant. So the graph is going to be like this, straight line. Okay? Okay. Now, this was maths. Let's come back to physics. Now before I go back to physics, just one more thing. I told you that we will come back to this. S is equal to 5t and S is equal to t squared plus, I think, 5t. This is the expression that I gave you before. And then I asked you to find the instantaneous speed. Instantaneous speed we found here as 5, doing some trivial calculations. Now we are coming back to physics already actually. So S is equal to 5t. Now S, I told you I am taking S for distance and t for time. So speed is distance upon time, or if we are looking for very small time interval, or if we are looking for instantaneous speed, then change in distance, very small, infinitesimally small, change in distance upon change in time. So speed is actually going to be ds by dt. That's why we studied dy by dx, to understand what would be ds by dt. And we also know how to differentiate. We know y is equal to 4x plus 5. We have learned and come that dy by dx will be equal to 4. We have learned this. Now if somebody says that s is equal to 5t, then it should be no trouble for you to find out what is ds by dt, just like dy by dx. ds, you are replacing y by s and x by t. So ds by dt is just the same as dy by dx. To find ds by dt, you have to differentiate this. And differentiation we learnt already. 5 will remain as it is. T has a power of 1. That power will come down and the power would be reduced by 1. 1 minus 1, you will have t ki power 0. That will be 1. So ds by dt is 5. See, the speed is coming out to be constant. That's why in our calculation the speed did come out to be same, both for average and instantaneous value. But now that was a very not so good kind of calculation, but this is the exact one. Speed is distance upon time. If you are looking for instantaneous speed, then you will have to look for instantaneous distance that has been traversed. That is very small distance that have been covered in very small time. That is ds upon dt. This is speed, and ds upon dt can be calculated using math as 5. So we see that speed is actually being constant. It is not dependent on time. So as you increase time, speed is not going to change. Speed is going to remain constant. And we call this as uniform speed. The value is not changing. It is uniform. So speed here is uniform, 5 meter per second. We also did some calculation for this, and we will revisit this. I told you, and we have revisited it. See, now if you're going to calculate speed for this case, speed you understand now is ds upon dt. Now for calculating ds upon dt, you just have to differentiate this expression. Differentiation of s with respect to time, because s is a function of time, right? Remember? So ds upon dt will be, you will have to individually differentiate both the terms. Differentiation of t square now should come out, it should slip out of your lips. 2t. Should have done practice. Plus differentiation of 5t again should slip out of your mouth as 5. Differentiation of t is 1. 5 is going to remain there as it is. So differentiation of t square plus 5t is 2t plus 5. You should you should build speed. Do it fast. So this is speed. This is speed actually. Speed is equal to 2t plus 5. Now if you remember, and you have to remember because I told you to remember, that the speed then which we calculated came out to be the speed at t is equal to 1 second. I asked you to calculate, and we did the calculation actually together, and we found the speed to be 7.001 meter per second. Now if you find instantaneous speed here, when you put t is equal to 1, you will find instantaneous speed to be 7, and we were pretty close but not exact. The exact value is 7. So that's why we study differentiation. It helps to do calculations in physics, which has to come from maths. So differentiation is a mathematical technique that we have learned, which will help us to find instantaneous speed, velocity, acceleration that we have not started yet, but it will, given the expression for the speed, acceleration and velocity. Once we have the expression, we can quickly do the polynomial differentiation, put up the value of time and get the exact instantaneous value of whatever physical quantity we are looking for. So that's what we have learned something. Now we have started the syllabus, we have studied differentiation. Now we have reached to our landmark. We have completed this differentiation. Now we'll do One more thing, actually